Hello, calculus students, seekers of general truth. We continue our study of exponential functions and logarithmic functions with cases of other bases, right? So let's think a little bit more about these scenarios where you have f of x equals 3 to the x. If you have a function like h of x is equal to e to the x, e actually makes life very simple for us. The derivative of that is just itself. But what if the base is an e? Okay, so our strategy here is to rewrite f of x in terms of e without changing the actual meaning of the function. Okay, so, and let's think of it this way. Rather than taking this derivative directly, right, we are going to take the natural log of both sides. So we're going to take the natural log of f of x and the natural log of 3 to the x. Okay. And then we'll do some simplifying. So the natural log of f of x is still the same on the left side. Over here, there's a property of logs that we can use that we can pull out the natural log. Pull out this exponent out to the front. And then now we can take the derivative. Okay. And the derivative of the right side is just the natural log of 3. Remember, this is a constant. Natural log of 3 is a constant times x, so the derivative is just the natural log. Over here, the derivative of natural log of a function is 1 over that function times the derivative of the inside here, which is f prime, right? And then we're going to rewrite everything again and say that f prime of x is equal to the natural log of 3 times f of x. So multiply both sides by f of x. So this turns out to be natural log of 3 times 3 to the x. And there you have it. We figured out the derivative, right, for the 3 to the x function. Okay. So this part of it here is done. What about the antiderivative? You know, it's nice that we can take the natural log of both sides and then figure out its antiderivative. Take its derivative. But this procedure that we did here isn't quite going to work when we apply to the antiderivative. The antiderivative of natural log is a little bit more complicated, right? So let's take a different approach with the second part here. Find the antiderivative. This time we are going to rewrite the number 3. Okay, seems crazy as it is, we are going to rewrite the number 3. So I'm going to say the following, that 3, right, is going to be equal to e raised to some constant, right? So e is 2.7 something. If you raise it to some particular constant, you will get the number 3. So now I'm going to solve this problem. We're going to take the natural log of both sides. So the natural log of 3 is equal to the natural log of e to the k, right? And that means we can pull out k to the front. Natural log of e is just 1 times k is just k. And so that means the natural log of 3 is equal to k. Therefore, 3, okay, let's make a bit of our conclusion here. Therefore, 3 is equal to e to the k. But k is equal to the natural log of 3. And so now we can take our antiderivative as follow. The antiderivative of f, which is 3 to the x, is really equal to the antiderivative. And again, we are rewriting the number 3. Okay, we're not doing anything special except to rewrite the number 3. So instead of having 3 to the x, I'm going to have e to the natural log of 3, that whole thing raised to the x, dx. Okay? And we can do some simplifying here. E to the natural log of 3 is really e e to the natural log of 3 to the x is really e to the natural log of 3 times x dx, and we're taking the antiderivative. Therefore, this is going to be, and we're going to use the property of e to the x here. So this is e to the natural log of 3x, right? Its antiderivative is itself, all divided by the natural log of 3. Okay? So plus a constant. So this is going to be our final answer for that particular problem. I'm going to squeeze that right in there. Okay? So you see here that when you have a base of something other than e, the strategy is really to convert it into something that looks like e. Because e to the x is very easy to take the derivative of it, and it's also very easy to take its antiderivative. All right, now let's move on to the general case, right? So the general case, given f of x equals a to the x, where a is some constant, and I should say that really a is a number greater than 0. Okay, all of this is, none of this stuff that we've been doing here really works if you have a negative base. Okay. All right. So if that's the case, then we can rewrite a. Right. Using the same process here, a is just going to be equal to e to the natural log of a. Right. I'll let you work out the details and practice this for yourself, but this is the result of, this will be the result rather, of that work. Okay, so any number is equal to, any positive number will be equal to e to the natural log of that same number. So therefore, f of x is going to be, we can rewrite f of x as, instead of a to the x, it's going to be e to the natural log of a to the x, or times x. So f prime won't be too hard to do. The derivative of e to anything is itself e to the natural log of a x times the derivative of the inside function up here, natural log of a. And if we rewrite this a little bit, this, remember, was all equal to a. So this is a to the x times the natural log of a. So the derivative, you can see that this process matches what we did up here if you replace 3 for a. And also, the antiderivative, right? So the antiderivative of f of x in this particular case is going to be equal to the antiderivative, let me change the color here, the antiderivative of e to the natural log of a times x dx, which is equal to e to the natural log of a times x, all divided by the natural log of a, plus a constant. And you can also see that this result here works out quite easily with what we have here, just replacing 3 for a. All right, so there we have it, the derivative and antiderivatives of a function where the base is not equal to e.